to code in Python, the beginner's course. Today we'll be looking at the basics in coding. I know most of you have heard about coding, but you don't know what it entails. So today we'll look at the basic one, which is called Python. But before we start, let's look at the context of software development. That's how a software is being made, or how a software comes about. A computer program, from one perspective, is a sequence of instructions that dictate the flow of electrical impulses within the computer system. As it says over here, a program is what determines how a computer behaves in every way, and that is what we call a program or a software. These impulses affect the computer's memory and interact with the display screen, keyboard, mouse, and perhaps even other computers across a network in such a way as to produce the magic that permits humans to perform useful tasks, solve high-level problems, and play games. So these programs or softwares, as we call them, is what affects the computer screen, the display, the keyboard, the mouse, and other parts of it, making you be able to interact with the computer in every way. So it's through a program that a computer operates. Without a program, the computer does not exist. Every software is what runs a computer. Without a software, the computer is dead. So the software is the main component, so the main component of a computer. One program allows the computer to assume the role of a financial calculator, while another transforms the machine into a worthy chess opponent. That's also what a program does, or software does. The concepts of computer programming are logical and mathematical in nature. In the theory, computer programs can be developed without the use of computer. Over here, it says that a computer can be developed without using a computer. It doesn't mean you can develop a software without accessing your computer. This is what it says over here. Programmers can discuss the viability of a program and reason about its correctness and efficiency by examining abstract symbols that correspond to the features of real-world programming languages, but appears in no real-world programming language. Thus, they sit down and discuss of how a computer or a program can be made, which means they can sit down and then think of how to create a particular program without accessing their computer. But that does not say they create a software or a program without the use of computer. That's what it says over here. While such exercises can be very valuable, in practice, computer programmers are not isolated from their machines. Thus, in real practice, computer programmers are not isolated from their machines. They are always with their machines. So if you're a programmer, don't expect to leave your computer behind. You surely need it. Software is written to be used on real computer systems. Computing professionals known as software engineers develop softwares to drive particular systems. These systems are defined by their underlying hardware and operating system. Developers use concrete tools like compilers, debuggers, and profilers. In this chapter, we'll look at the context of. In this chapter, we are looking at the context of software development, including computer system and then the tools. So now we are done with chapter 1. Let's go on softwares. We are still on chapter 1. Computer program, that's we are now on a software. Computer program is an example of computer software. So the program that we saw at the first part of it is also known as a computer software. Everything that you see on your computer that you are able to interact with is a software that is being programmed onto the computer to make all for a specific purpose. One can refer to a program as a piece of software as if it were a tangible object. But software is usually quite intangible. The reason why this one is saying that is when you look at the existence of a software, it doesn't make actual sense in our real world. But for computer, its language is what it speaks through its ways to interact with we human beings. That's the software, how a software come about. But to think about it, how it being made, it doesn't make an actual tangible reason. It is stored on a medium, a hard drive, a CD, a DVD, and a USB pen drive are examples of media upon which softwares can reside. These are the places that softwares can reside, no other places. The CD is not a software. The CD is not the software. The software is a pattern on the CD. The CD is a medium on which the software is located, but the CD itself is not a software. Instead, the software is a pattern on the CD. In order to be used, software must be stored in the computer's memory. In order for a software to be accessed or be used, as it being said over here, it must be stored in the computer's memory. Typically, computer programs are loaded into memory from a medium like the computer's hard disk. They are loaded onto a memory, which is also called the computer's hard disk. An electromagnetic pattern representing the program is stored on the computer's hard drive. This pattern of electronic symbols must be transferred to the computer's memory before the program can be executed. Let's read again. It says an electromagnetic pattern representing the program is stored on the computer's hard drive. This pattern of electronic symbols must be transferred to the computer's memory before the program can be executed. You see how a software is being displayed over here or is being accessed over here. This electromagnetic pattern representing the program, as it says, is stored on the hard drive, and on the hard drive it must also be transferred to the computer's memory in order for it to be accessed or in order for it to be executed. That's when you can be able to open your programs or your software and then it runs, because it is stored on the computer's hard drive and it runs directly to the computer's memory, and it gives you the access to be able to use the particular software that you click on. The program may have been installed on the hard disk from a CD or from the internet. In any case, the essence that was transferred from the medium to medium was the pattern of electronic symbol that directs the work of computer system. This pattern of electronic symbols are best represented as a sequence of zeros and ones, digits from the binary base 2 number system. An example of binary program sequence is the binary programming sequence. So this is the language at which a computer speaks. The computer does not speak our normal language, our normal English language that I'm standing here and I'm reading over here for you. This is its language. It only understands zeros and ones. That is what a computer understands. So when you are creating a program, this is what is being translated into the English that we can understand and then read. But in actual sense or within the computer itself, this is what is written inside and this is what it understands. But it's translated using the softwares that we create for it to be able to understand, or for we to be able to understand it. To the underlying computer hardware, specifically the processor, a 0 here and 3 ones there might mean that certain electrical signals should be sent to the graphic device. Let me read again. To the underlying computer hardware, specifically the processor, a 0 here and 3 ones there might mean that certain electrical signals should be sent to the graphics device so that it makes a certain part of the display screen red. So this number that I see over here, that you think is just a digit that has been written, to the computer it understands it in this way. that the zeros here and then the 3 ones over here is electrical signal that should be sent to the graphic device so that it makes certain parts of the display screen red. So the way you see this display screen over here, white with the rating and other things that we see on it, they are all rated in these particular figures or these particular digits that we see over here. This is not how a computer is being programmed in this English way. No, it's not. It's programmed in these digits. It's only few people who are able to enter these particular digits in real life. It's only few people. Unfortunately, only a minuscule number of people in the world will be able to produce by hand the complete sequence of zeros and ones that represents the program Microsoft Word for an Intel-based computer running the Windows 8.1. Only few, which means there are people who are able to write the digits for a computer to understand without using any other software, but they are able to write a digit for the computer to understand it and then run it for us or translate it for us to be able to access it. They use the digit to be able to program the computer. So, by hand, the complete sequence of zeros and ones that represent the program Microsoft Word for an Intel-based computer running the Windows 8.1 operating system. Further, almost none of those who could produce the binary sequence will claim to enjoy the task. I tell you, if you are asked to enter these digits in order to create a program, you will feel very, very frustrated in doing so because this is a very tedious work to do. Even though this is the language by which a computer mainly speaks, yet it's only few who are able to enter this particular digit for a computer to understand and for it to work in actual real life. Okay, let's come to programming languages and then development tools. Software can be represented by printed words and symbols that are easier for humans to manage than binary sequence. Tools exist that automatically convert a higher level description of what is to be done into a required lower level code. Higher level programming languages like Python allow programmers to express solutions to programming problems in terms that are much closer to natural language like English. As it says over here, that higher level programming like Python allows programmers to express solutions to programming problems in terms that are much closer to a natural language like English. So Python over here is a language, as we all know, is a computer language that translates these digits that we saw over here, these digits. It translates the digits into actual English for we humans to understand it, because we cannot speak the computer language. We cannot see these digits and then tell what it's saying. No, we don't understand it. So these softwares or Pythons are created which translate those digits that we saw into actual language for we accessing the computer to understand it. And that is what we'll be looking at, how to use this particular software or computer language known as Python into creating something that we can understand and others also can understand as well. Some examples of more popular of hundreds of higher level programming languages that have been devised over the past 60 years include Fortran, COBOL, Lisp, Haskell, C, Perl, C++, Java, and C#. So all these ones are computer languages that are used in translating those. So, as we were saying, most programmers today, especially those concerned with high-level applications, usually do not worry about the details underlying hardware platforms and its machine languages. Programmers have a variety of tools available to enhance the features, to enhance the software development process. Some common tools include, now let's look at the tools that are used in developing these programs, or the tools that help us write the codes. First of all, let's look at the editors. An editor allows the programmer to enter the program source code and save it to file. The editor allows the programmer to enter the program source code and save it to files. So it's the help of the editor that allows you, the programmer, to write the code into a source code, and then you are able to save it to a file. It's the help of the editor that does that. Most programming editors increase programmer productivity by using colors to highlight language features. Thus, through the help of these editors, or most editors nowadays are being highlighted with colors, which helps you, the programmer, to be able to identify the particular code you are writing. If it's an error, it gives a different color. If it's correct too, it gives a different color. So this editors helps you in your coding, or it makes it more easier for you to code. The syntax of a language refers to the way pieces of languages are arranged to make well-formed sentences. The syntax of a language refers to the way pieces of a language are arranged to make a well-formed sentences. To illustrate the sentence, let's look at this sentence. In real life, or in real English, this is what we will write, and this is what we understand as humans. The tall boy ran quickly to the door. That's what you know that is correct. I also know is correct. There's the use of proper English syntax. By comparison, the sentence, this is what the computer also understands. Boy the tall runs door to quickly there. See that they are not in correct syntax to the real life English that we understand. So in translating a computer program or coding, this is what you end up writing. And this is how the computer understands a language. It's not like how we follow, or we don't follow the actual English standard in coding. When it comes to coding, we have a different way by which it's being written. As you see, boy the tall runs door to quickly there. It's not correct syntactically. It uses the same word as the original sentence. That's, it uses the same word over here. Original sentence, by the arrangement, does not follow rules of English. That's how coding is done. The arrangement does not follow the rules of English. That's how coding is done. Similarly, programming languages have strict syntax rules that programmers must follow to create well-formed programs. They have strict syntax rules, which means if you make mistake in this syntax rules, your program or your code is wrong. There will be an error inside your code, or there will be a bug within your code. So you must check well, or you must follow the strict syntax rules in order for your program to be well, or be a correct program. Only well-formed programs are acceptable for translation into executable machine codes. You don't just write any program at all and accept it to be translated. You get an error. So only well-formed programs are acceptable for translation into executable machine code. Some syntax-aware editors can use colors or other special annotations to alert programmers of syntax errors during the editing process. As we said earlier, this syntax helps the programmer be able to identify errors by using colors to prove that this particular part of the code that is written is an error. Mostly errors are written in red lines and then underlined. Let's come to compilers. A compiler translates the source code to target code. A compiler translates the source code to a target code. Let's see what editor does. Editor allows the programmer to enter a program source code and save it. So after the editor has allowed you, the programmer, to enter the source code and save it, Now, the compiler translates this source code that you have entered into a target code. The target code may be a machine language for a particular platform or embedded device. The target code could be another source language. For example, the earliest C++ compiler translated C++ into C. The earliest C++ compiler translated C++ into C. C is a language. C++ is also a language. They are all languages. But this C++ translated or compiled the language into C. Another higher level language. C is also another higher level language. The resulting C code was so, as we see, another level language. The resulting C code was then processed by compiler to produce an executable program. Compilers today translate C++ directly into machine language. Compilers translate the content of a source file and produce a file containing all target code. Popular compile languages are C, C++, Java, and then C#. Let's come to the interpreters. An interpreter is like a compiler in that it translates higher level source code into target code. So interpreter is more like a compiler, but it translates higher level source code into target code, whilst a compiler translates source code into target code. But with the interpreter, it compiles higher level source code into target code, usually machine languages. It works differently. However, while a compiler produces an executable program that may run many times with no additional translation needed, an interpreter translates source code statements into machine language each time a user runs the program. It says over here, while a compiler, that is this compiler over here, produces an executable program that may run many times with no additional translation needed. It can run many times with no additional translation needed. But interpreter translates source code statements into machine languages each time a user runs the program. So which means interpreter reinterprets anytime you try to run, it must reinterpret. A compiled program does not need to be recompiled, as it says over here. It does not need to be recompiled to run, but an interpreted program must be reinterpreted each time it executes. That is the same way that is saying over here that interpreter translates source code statement into machine language each time the user runs the program. So for an interpreter, it must be reinterpreted, but for the compiler, it doesn't need to be recompiled. The interpreter is in essence reads the script, where the script is the source code of the program. In general, compiled program executes more quickly than interpreted program because the translation activity occurs only once. So a compiler is more faster than interpreter because it runs only once. Interpreted programs, on the other hand, can run as in on any platform with an appropriate interpreter. They do not need to recompile to run different platforms. So with the appropriate interpreter, it can run on any platform at all. With the interpreter, with a correct interpreter, it can run on any platform at all, and it does not need to recompile to run on any different platform. Python, for example, is used mainly as an interpreted language. So as we can see over here, Python is an interpreter language. Python is not a compiler. Instead, it is an interpreter language, or it interprets language. But compilers for it are available. Python, as we know, is an interpreter, but you have the compilers too that are available for it. Interpreted languages are better suited for dynamic explorative development, which many people feel is ideal for beginning programmers. Interpreted languages are better suited for dynamic, or let's say Python are better suited for dynamic explorative development, which many people feel ideal for beginning programmers. So as a beginning programmer, your best language to use is Python. I'm not saying it's a force to use Python, but if you want to know the basics of programming, I would prefer to try or go and learn from Python. Popular scripting languages include Python, Ruby, Perl, and web browsers, which are JavaScript. So popular scripting languages including Python, Ruby, Perl, and for web browsers we use JavaScript. Let's come to the debuggers. A debugger allows a programmer to more easily trace program's execution in order to locate and correct errors in program implementation. A debugger allows you, the programmer, programming or coding, to easily trace a program's execution in order to locate and correct errors in a program implementation. So a debugger helps you, the programmer, finds out errors in a program before you end up executing the program or bringing the program out. So with the help of the debugger, that identifies errors in a program, so that you, the debugger, you don't get much tough time after you've compiled, after you've interpreted your language, after you've done everything with your language or your program or your coding, then later on you find error in it. No, with the debugger over there, errors are easily identified and it makes you, the programmer, your work more easier. With a debugger, a developer can simultaneously run a program and see which line in the source code is responsible for the program's current action. With a debugger, a developer can simultaneously run a program and see which line in the source code is responsible for the program's current action. So that's the help of the debugger. It helps you, the developer, to simultaneously run a program and see which line in the source code that you are writing is responsible for the program's current action or current error. The programmer can watch the values of variables and other programs elements to see if their value changes as expected. Debuggers are valuable for locating errors, also called bugs. Debuggers are valuable for locating errors, which are also known as bugs, and repairing programs that contains error. So the debugger helps locate and then repair errors. Now let's come to the profiler. A profiler collects statistics about a program's execution, allowing the developer to tune appropriate parts of the program to improve its overall performance. So this profiler over here helps you, the developer or the programmer, to tune the code or the program that you are creating to improve its overall performance. So maybe you are running a program, you are creating a program which you want it to run right, but the program is running left. With a profiler, it helps you to direct the program to run on the right route that you want it to run. That's what the profiler also does. It shapes a program to run on the actual way at which you, the developer, you want it to run. That's what a profiler does. It's more like a debugger, but it's different from debugger, because debugger identifies error. By the profiler, it helps you, the developer, tune in the particular program you are running to the right route. A profiler indicates how many times a portion of a program is executed during a particular run and how long the portion takes to execute. So it tells you, the programmer or the developer, how many times your program is running and how long it takes for it to execute. So you know how to plan your particular program you are running, and you know the particular systems it can run on. That's the help of the profiler. Developers also can use profilers for testing purposes to ensure all the codes in the program is actually being used somewhere during testing. This is known as coverage. It is common for software to fail after its release because users exercise some parts of the program that was not executed anytime during testing. The main purpose of profiling is to find parts of the program that can be improved to make the program run faster. That's the main purpose of the profiler. It helps you, the developer, identify parts of the program that can be improved to make the program run faster. So now we have seen the tools or the development tools used in the computer languages or used in coding. So our next lesson or our next chapter will be on what is Python. We will jump right into what we are mainly here for. Python, what Python really is. We will now jump into it this time. So next lesson is going to be on Python, mainly on Python. So don't be left out. Join in the next lesson. I'll be expecting you, and thank you for participating in this lesson. Don't forget to subscribe. Thank you.